Unifesp, Science and Technology Institute here in San Jose dos Campos. So welcome everyone. And I'm very happy to introduce this roundtable discussion that we were all eager. So we're getting actually more students coming in. I'm very happy to see that. So we were very eager to come to this third day. So the topic of this workshop this year, of our workshop, is AI in healthcare, broadly speaking, which is obviously probably the single hottest topic in medical research nowadays. So we decided to dedicate the workshop to this, and especially, of course, this roundtable discussion. So we have three great contributors. And I will give the word to Adenauer, who put a lot of time into thinking of this meeting and session so that he can put our discussion from today into some context. Okay, Adenauer, please.
Okay, thank you, Federico. And well, of course, it's a great pleasure to have you all here, to welcome you all to this virtual roundtable on artificial intelligence and biomedical engineering. And well, I'd just like to take a brief moment to set the stage of the overall purpose of the session, also for our students here. And well, Federico already told you that the topic of this workshop this year, we have this workshop every 2 years. Last time it was biomedical engineering COVID for obvious reasons, 2 years ago. And I think that now, again, unsurprisingly, we are with the spotlight on artificial intelligence and its application in biomedical engineering. And the reasons relate, of course, with what we have been seeing very recently when this topic has, let's say, captured the attention of the general public, right? Largely being driven by the advent of this more accessible and powerful tools based on large language models like ChatGPT and so on. And a lot is being discussed right now about how these models work, how come they do what they are able to do, how these models have begun to achieve some important degree of generalization, maybe in terms of their functionalities. And of course, I would like to say that we are not yet, although the title of this hot topic session is about the future and artificial general intelligence, we are not talking about artificial general intelligence yet, but the path we are witnessing is one of a progressive generalization, I think. So Professor Vicent gave us a great overview yesterday of the area in his talk. And if we take, let's say, standard machine learning models, what we have there are algorithms designed to classify patterns within very specific feature spaces that are suitable, let's say, for specific problems. And then when Professor Vicent showed us that we have the evolution from neural networks to deep learning systems, we see a leap in generality. The systems began to work on problems without a predefined feature space, like the feature like emerged from the network itself. And although they are still designed for specific functions, such as image analysis, audio signal processing. And now this I think, has changed with the emergence of what are called these foundational models, where a single system begins to have more generalized capabilities in which the functions somehow also emerge from the machine. So although these are not AGI models, we are going toward generalization. And people are starting to talk about sparks of artificial general intelligence, which is a title of a Microsoft report on their amazing results with GPT-4 in the beginning of this year. And it is for this somehow surprising, I think, generality and emergence of functions that the attention of the general public, including governments, has been drawn to these tools. And so what we like to do, I mean, there are topics like ethical concerns, privacy issues, impact on the job market, on education, and even on how this technology makes us interact with each other. All of these topics are now on the agendas of various research and regulatory bodies, right? And of course, healthcare stands out as one of the most significant applications for this. And it is in this setting that where generative models are a reality and where people talk about sparks of AGI, that we are very pleased to have you here today to try to understand the impact of this technology on the future of medicine, and particularly on the future of biomedical engineering, which is the area of our students here. And this was our goal and motivation to have with us here today. And we have three fantastic professionals, researchers, and thinkers with distinct backgrounds and who are working with AI from different perspectives, I believe. And our idea, Federico and mine, was, but also in the name of the whole organizing committee of the workshop, is to take this opportunity to hear your perspectives about the future, mainly, of AI and medicine and the future of biomedical engineering. But so before talking about the future, I think we can start from where we are, right?
That's exactly.
That's the idea.
So, and especially in order to introduce where we are now, I would like to give the floor to Dr. Livia. We thank you again for accepting our invitation. This is your debut here at our workshop, unlike your two colleagues who were with us the past 2 days. So, Livia, if you want to go ahead with your initial contribution, initial presentation, we're eager to see what you're going to show us, and then we'll start from there. So hopefully, I don't want to overload you with too big of a task, but we really look forward to hearing your point of view from someone who's in a hospital setting, because at the end of the day, and both Dr. Paulo and Dr. Vicent have shown us in the last 2 days how important it is to remember we want to answer questions. We don't want to just analyze data, because these questions have to be closely related to the bedside or the clinical setting in general. So Livia, please, and thank you again for being with us.
Thank you, Federico, for the invitation. Thank you, everybody, for having me here. It's a pleasure to speak to you all. I'm not going to apologize for my English, but I'm just going to let you know my English is not that good, so I'm trying to make stuff. If you don't understand anything I'm saying, just please let me know, and I'll try to rephrase my talk. So I'm Livia. I've got my undergraduation in biomedical informatics, so I'm not exactly an engineer. I have almost a decade in IT, working with a lot of projects in different aspects, and got my master and my PhD in public health. So I'm kind of a duck. I'm not flying well. I'm not swimming well, but I'm in the middle of these two storms that we have in IT and health. About generative AI, about what I do in Einstein, I'm an innovation coordinator. I have a team that works with different tasks. We get some investments from industry and develop some models to them to improve their products, test some risk projects that they wouldn't have inside the company, but we can do this in our institute. About the AI, this is something that is very close to my heart since the beginning of my career. In my PhD, I have opportunity to work with the traditional models to predict if a woman would die or not during labor. We have data from 10,000 women in Nigeria and Uganda, and we try to find there are signs that would indicate if the woman is going to have a bad outcome or the baby would have a bad outcome. And what you saw through the data is that the AI couldn't answer that question. So although we try a lot of techniques, a lot of ways to respond to this question, what we found is there's no pattern inside the data. So first point in this talk, AI cannot solve all the problems, or at least machine learning can't solve all the problems. But we find a way to make it different. When we realized the data wasn't enough, wasn't the answer we are looking for, we go for the expert knowledge and try to do different type of agent. Not an agent who works from data, but who works from the specialist knowledge. From this project, we published around 8 papers with this algorithm using business process notation to say what the paths, which paths the professionals, the health workers should take based on guidelines from WHO, World Health Organization, for NICE, another institution for England, United Kingdom, and we went for this with expert knowledge, not only data. So first of all, AI is different than machine learning. I think everybody knows that. And sometimes we forgot, and we always try with data. We try this different type of approach. It worked. We have some papers. We have, of course, we still have to prove the concept we have, but at least we have a lot of a huge body of knowledge and easy techniques to put inside the computers and the codes that could answer and help professionals. About the generative AI. I am lucky enough to tell you that I just arrived from Dakar, Senegal, where I presented a project from Einstein where we are testing LLMs for antenatal care. We won, it's not a prize, but we won some money from Gates Foundation to test if LLMs can help us during consultation. My camera just froze. Okay, sorry guys. Can you listen to me? No? Okay, no problem. Can you listen to me? Okay, sorry.
Yes, yeah.
We just developed this system where we can listen to the consultation, the antenatal care consultation, and give answers to health professionals. So if they forget something on the protocol in antenatal care, if they need to ask him more questions, if they have some diagnoses that kind of rare, we are trying to verify if this type of model can help health professionals. We're taking this approach very slow. So this first step, we're going to just check if this techniques is safe and useful for health professionals, safe for both of them, for the woman, the baby, and the health professionals, and ask for the professionals if it was useful enough so they could offer that or indicate that for another professional to use. This is our first step. This is where you are. But what I learned in this meeting from another researchers that was there, because this edital, this call for proposal, they received around 1,000 of submissions. We have 6 submissions from Brazil that was accepted, and 50 in the world. So our group was there, and we were checking where AI could fit. What we realized is here in Brazil, what we're looking for is some ways to improve healthcare. Because I know we have a lot of problems in our health system, but at least they exist. It exists, it helps people, and the AI is here to help us improve the care. In other facilities, in another context, sometimes the AI kind of have to replace the health professional, not because they are not good, but sometimes because they don't exist in that context. So what you saw in some in development countries, it's especially low-income countries, they don't have health professionals. They have to use this type of AI. And it's good because at least now we're find a way to help, to give some kind of care, but we still don't know if it's safe. So the big question there was how we can make these projects and these ideas ethical, safe, and useful for the people who have to use it. So thank you. I speak too much, so if you want to stop me, please just let me know too.
Livia, what was perfect? Absolutely, you didn't speak too much at all. Actually, you gave me a great assist for getting really into the thick of our discussion, because one of the first things that Adenauer and I were debating in the last few days, since you're bringing the perspective of someone who works in a hospital, was the issue of infrastructures. there's a lot of talk about advanced data science methods, AI, okay? And sometimes, especially, I will just bring a little bit of my expertise here. I see that people completely forget how easy it is to, or hard it is to deploy an advanced decision support system, for example, to the clinical setting. Why do I say why did I mention my expertise? So as Vicent very well knows, since we've also been working together on common projects in this field, my research has been dealing with critical care problems for the last decade or so. And I remember that some years ago already, before all this AI frenzy, there were some doctors, I remember especially, I won't make names, even if I'm talking about a super smart researcher, not just a very good intensive care doctor, a super smart researcher. But anyway, I was very impressed. That was probably around 2018. This idea of transitioning to the EICU, okay? However, I stopped a second, and definitely, you know, after I moved to Brazil, I even got a stronger feeling of this infrastructure issue. And Brazil doesn't even compare to countries like the ones you mentioned. You mentioned Nigeria, you mentioned Uganda, you mentioned you were in Senegal. But anyway, okay, you may be able, I'm sure that Vicent can also chime in on this later, you may be able to push forward some EICU, EOR idea forward if you work in the best hospital, not in any hospital, by the way, the best, most advanced hospitals in the US, Canada, Europe, some Far East country, the best hospitals, not any hospital in these countries. This is insane to think that can be deployed to the clinical setting in any developing country, just insane to think. So we cannot push forward ideas that are so far from reality for 90% of the world population, in my opinion. And maybe we'll also, touch onto this later, because we also, at the end of this discussion, we'll also gauge your opinion on ethical implications. Anyway, let's talk about infrastructures. So I took advantage of what you just mentioned, and I came in with this comment from my end. And I would like to involve all of you, starting with you, Livia, again. What are the main issues, infrastructure-wise, that you can observe in a hospital? Also, Albert Einstein is actually a very good hospital infrastructure-wise, for not just for Brazil, okay? We've been hearing about big data long before AI became a common label, passwords, keywords, you name it, okay, in the debate. Big data has been around. We saw Dr. Paulo's presentation, Dr. Vicent's presentation the last couple of days. This is not a new term. However, there are, I would say, the issues of collecting the big data, accessing the big data for a researcher or a healthcare professional or the hospital management, so on and so forth. Storing the big data. We've seen companies, I remember Philips a few years ago launched a massive initiative on the cloud storage of hospital data. So I would say these three, maybe correct me if I'm wrong, maybe the main issues: collecting the data, accessing the data, storing the data. And then there are some collateral problems like curating the data. This is big as well, but I would say maybe comes second. First, you have to collect the data, store the data, access the data. Then you have to curating the data, standardizing the data. Okay, so if we can dedicate the first chunk of the first block of our conversation, maybe 10, 15 minutes, the three of you, at an hour as well, to this issue, I think we'll move forward well. Yes, I would say, Livia, if you can give us just in a few words, a few minutes, your perspective, what's the story with Einstein, for instance, and then we'll move on to Paulo and Vicent. Thank you.
Well, let's talk about data science and the problem of the data. First of all, sometimes people forget about the part of the science in data science, because they just go with techniques, they just go to run some algorithm and get some answers. But we know that garbage in, garbage out. We know that if you don't have a good data to use in your AI or whatever thing you're doing, you're not going to get good results, or wouldn't like it, you won't be useful for anything. So
Livia,
first of all,
Livia, can I interrupt you just a second? Because there's something that I wanted to remind later, so I'll take advantage of this now. We were all impressed here. This looks like a simple thing, but I think it was a great bit of knowledge that Paulo shared with us the other day. So there are too many researchers that think, okay, I finally have the data. Let's get something out of the data. And he said something that every researcher and we as educators in higher education should always remember. We have to teach first to ask questions. So Paulo, I'm kind of citing you. It's not literally quote unquote, but I think that's one of the key messages that you mentioned the other day, you brought the other day, right? So I want to take advantage of this, Livia, because we were going to mention this later on. So I mentioned this now because really, okay, we have the data, and so what? Too many papers get out. I'm not gonna say they're garbage out, but no one is gonna read them. No one is gonna reproduce those analyses. The clinical problem, if there's any, or even physiological, basic sample, is totally irrelevant. I'm not advocating here a market-driven research only. I'm just saying, do you have a question, or are you just displaying your magnificent methods to get an answer to get no answer because you had no questions? Sorry, go ahead.
No problem. It's just something that I feel because people get very excited about using the data that they finally got, but they forget there's to think about the hypothesis they had to test, the way they have to test, and for which reason or whatever reason they want to test that. Because we have to remember, AI is expensive. AI costs money, costs the environment, because LLMs also have this big question about how much carbon we're throwing on the world because we are using this kind of modules, because they heavy, expensive. We have a big machine here in Einstein that costs more than $1 million. And for the project we're doing for Gates, we're using half of this machine. So it's very expensive. So we have to think about it. So science first. Science is the base of everything we do, especially in health. We need to be sure that whatever you're putting outside of our group of researcher or our products, the data products we create, that it must have been based on science and good science. About the other questions you have made about storage of data is also expensive, but at least here in Brazil and other countries, you have to keep your data. Anyway, if it's a good data or a bad data, you have to keep it at least for 5 years. This is the law. So this is something that you're not going to overcome if you have or not have good infrastructure. So, okay, this is basic. We have to get this. The problem is the second step. The data we're storing, it's good or accessible, because some people can store data in paper. Like if you go to some primary healthcare facility, you have a lot of data there in papers. Are you going to use that? Of course not, because it's not possible to work with the amount of data, especially because it's not in the computers. So, okay, we need to solve this first problem of digitalizing the data we have to get. Of course, this go beyond a lot of other problems like infrastructure, like electricity. There's places there's no electricity. I visited Amazonas in August, and to get to some cities, it took us around 3 hours, and we kind of the metropolitan area of Manaus. It took me 3 hours in a really bad road to get in the city. So, and there, the city was amazing, it's beautiful, but we have problems to get that's beyond what you're trying to solve here. So storage, we need to digitalize the data. We need investments for a lot of sources to put this on track and give us the chance to have this data on computers. The second step, when you solve this part of problem, if you go to the best hospitals or best health facilities units, you're going to have data. You're going to have a digitalized data. But we know that only data is not enough. You need to get this to the level of information and the level of knowledge. To do that, you have to have some good ways to check quality. Because it doesn't matter if you have a lot of data, if all the data is bad. Like for COVID, we have a lot of models out there checking a lot of X-ray from chest that wasn't reproducible because the images was not bad, was not good. The result was not especially reproducible. So that data was from real world or was something more kind of lab data that is very perfect. It doesn't reflect having the practices. So the quality, it must be somehow protected to get other stuffs on top of that. So more than storage, you need more than big data, we need good data. Because as I said before, I have 10,000 women in labor. It was a huge database, something that we didn't have before. And you have timely hours from pregnant women giving birth. Like we have a lot of points to check, and everything didn't work because the data, maybe the data was good, yes, but like didn't reflect the problem. So more than data, we need good data. We need to create it. This also is expensive. This also is problematic and takes a lot of time from data scientists and health professionals to be sure the data is good. So I don't know if this answers your question, but like
it did, absolutely. And actually, again, you're serving me another assist to move on to Paulo and Vicent, because I would like to have them commenting a bit also on the infrastructure issues, but then we will take advantage of this discussion on which we think is preliminary to other topics about infrastructures, because there's one aspect, I mentioned collection of the data, access to the data, storage of the data, curation of the data, and standardization. But I didn't mention yet, because we're going to move now little by little into this, and that will involve, as I said, Paulo, Vicent, Adenauer, possibly Mateus, if he's still with us. There's another issue with the data, which is trust. So we can talk all we want about infrastructure, and I would like first Paulo and then Vicent to comment quickly on this. But then there's the problem that even if we have the infrastructures, and as Livia said, and as Paulo said the other day, we have the hypothesis, we have the questions, and we have the methods, and we have the money and the resources, as Livia said, to do this. There will always be the problem of how we, even in the presence of all the infrastructure in the broadest sense, how do we accept or make these technologies accepted? Is there trust into them? So Paulo, and again, I hope that I didn't misquote you before, but you're free to correct me now that the floor is yours.
Okay. You didn't misquote me, and absolutely, I was agreeing with everything that Livia said, completely. I was trying to resist showing some other stuff because we did some work on pregnancy viability. We did, this is with data from Europe as opposed to data from Africa. And we did get predictions, and we also, I can show you if you want, just what we got. If you just have a second, because you might find this interesting. Share. There you go. Is he going to share my whole screen? Or is he sharing something? Okay, sharing the whole screen. That's okay. So, oops. I had this on viability, but there you go. So, the kind of data we had was this. So it's age, it's information about vascular pain, sac diameter, so ultrasound information, fetal heart rate information. These are things which will be present in probably most European, American, Brazilian hospitals in cities, I guess, in main cities. They may not be available everywhere, and I come from Mozambique. I'm sure that in the countryside you wouldn't have most of this, but if you do have this information, we utilized an SVM with radial basis function to do it, which is a kind of a black box. But the whole point of this work, done with someone called Vanja van Bel from Leuven, was to interpret. So we got some decent area under the curve, but it's this other method that was interesting. We opened up this RBF SVM, and we used exactly the analysis of variance methods that I talked about. So we are able to produce a model that was fully interpretable because it not only used different variables, but the contribution to the log-odds ratio of the model that came from each of these variables was precisely quantified, and we could properly understand it. So I'm not a clinical expert, though I've done some other work on low birth weight births in Peshawar, in Northwest Frontier Province in Pakistan. So I have a little understanding of this field, but I do understand, for instance, that this is the viability, so it's the inverse of mortality, right? In fact, this wasn't about mortality, this was about viability in terms of some clinical measure of a healthy baby. But I do understand, for instance, the dependence on age makes perfect sense, that the viability of birth increases as the woman gets towards the end of teens into the 20s, and then there's usually some more concerns about what happens after 40, and there's different theories about this. Some theories around the ability, the fitness of the mother at the early ages, and some fitness about the quality assurance of the fetus, the DNA transfer and everything else at the second later age end, and this is the histogram of mother. So that's the contribution from age, was exactly this. But what was interesting is that we picked up other things for discrete variables, but also interactions between fetal heart rate seen or not seen and mean gestational sac diameter. There was an interaction that if the fetal heart rate was seen, then if the gestational sac diameter was big, then that indicated a lowering of the viability. If the fetal heart rate was seen in a particular way, then the increase in gestational sac diameter showed an increase in viability, and here are the data, and also an interaction between the mean yolk sac diameter and vasculature. So what I'm trying to say here is that it is possible to get transparent models that have good match with clinical expertise. Now, while I'm sharing, might as well share the other screen I was going to share, so that way I don't have to share very much. And this is switching on to what Livia was saying. This is one of the slides from my talk, and one of the slides that I think Federico was alluding to, namely that when you look at good practice for decision support systems in healthcare generally, you find that the thing that is often most important at all is the question you ask. So for instance, the thing that you need to do first is to engage with the relevant stakeholders. The stakeholders can be varied. They can be care workers, and they can be nurses, they can be doctors, they can be public health workers, they can be hospital administrators, whatever, or they can be radiologists in the case of imaging. But the most important thing is, if you're answering a question, or if you want to show a benefit within a specific context in healthcare, who's involved? Because you're going to help somebody and that somebody works within a workflow. So what is the workflow? And then you produce the question, how are you going to create benefit to this person, the stakeholder, within this workflow, right? And one thing which I didn't indicate here, because believe it or not, a lot I didn't say in the talk, even then it was too much information, but one thing that's missing here, which is fundamental actually, and this roundtable is raising it to the surface, is this very important question that when you know who you're going to help and you know the workflow that you're going to want to help with, how do you measure success? How do you measure benefit? It's not as simple as an area under the curve. There can be lots of other things. There can be calibration. There can be stratification. There can be lots of things. And the statistically is very important to ask that question. If you are going to have benefit, how do you measure, how do you quantify that benefit? And only then do you specify the technical aspect. And again, something else that's missing from here is the data. I've talked about the model, and the model needs to be plausible, and you need to indicate how this model fits into that infrastructure that exists in the workflow, and then you need to validate. But the data is absolutely fundamental, but the data needs to be sourced, right? The data needs to be sourced in order to answer the question that is relevant, as opposed to what a lot of people do, which is to start with some data set and then with a method and say, what can I do? What can I achieve if I apply this method to this data set? That's fantastic for training. I don't have a problem with doing that. I think for students, undergraduate, postgraduate level, even early PhD level, is a fantastic way of it's the only way to get people to understand machine learning, is to have some data and have some methods. But if you're then talking about real application in the work, in the care setting, you do need to go backwards, and you need to ask, what is the data that I need? And all the data of a sufficient quality? What are the issues around data in terms of maintenance? And how can I curate the data? How can I update the models? How can the doctors understand the data? And how can the doctors understand the models? And when you've done all of this, you then need to demonstrate that you got value. You've got to demonstrate through some comparison, which usually is some form of randomized controlled trial. And that's very, again, in my talk, I explained that if you look at the literature, there's a lot of evidence that's often not done sufficiently. Then there's the fact that your models need to be operated in a prospective setting, which is, again, is very rarely done. They need to be validated in a multi-center setting, which is extremely rarely done, etc. So I've given you a long answer to a short question, but I'll want to just show you one more slide, and then I'll be more direct on my answer, because all this introduction is going somewhere. And I promise this is the last slide I'll show. It's again from the talk, because the question you were asking, Federico, and the question we're addressing here is actually extremely broad, and extremely broad because healthcare is not just the hospital. And even within the hospital, you have extreme differences in specialisms. And even within a specialism, you have different tasks which you may benefit or not from AI in. But we need to consider what is the future of AI. And one good way to do that is to look at the trajectory. Let's look backwards, like a car gaining speed to overtake, and you say, right, let's look back and see where we come from and where does this lead into the future. And the things that have happened in the past, or all the things that I mentioned that are very limited in scope, they, as Vicent pointed out in his talk, so I understand, is to do with models that have very limited scope. And even then, they're not often very much used. And then we got deep learning, but deep learning does have issues of reproducibility, of understandability. And then you have generative methods, okay, which open the door beyond tables of data and beyond images, but onto natural language and text, which can have applications in all kinds of things, from natural language processing of notes through to systems biology and genomics. But what seems to be happening is that we're developing the technology very, very fast without necessarily engaging enough with the healthcare experts as to where they need the technology. It's like we're developing a Formula One car, and then we're coming back to traffic time, peak traffic time in Rio or São Paulo, and say, we got this fantastic car, and it's really very fast. You say, fantastic, but I can only drive it at 20 kilometers per hour, half the time. And in any case, I got 3 kids, and I also got a big load I want to carry with me. And so your Formula One car may be fantastic, but it's not for me. So what I see with the advances in data, in electronics, in technology, is that we now can realistically look at the full spectrum of healthcare, which is in front of us on the screen, right from very specific genomics of disease and epigenomics, right through what we saw coming to a large presence during the COVID years, which was the role of social media, both positive and negative roles, how to control, legislate for that, and everything in the middle, okay? The bit that we talked about in terms of hospitals is one line, is the clinical data, which can be tabular, can be structured, can be images, can be electronic signals like ECGs, it can be waveforms such as for blood pressure. There's a lot of need in all of these things. There's a lot of need in all of these. And if you're a student, you now have the technology to be able to address any of these different areas, but you do have to remember, well, same thing for member staff, same thing for research, same thing for me, okay, same thing for all of us. But what we all have to remember is that we always need to start with the question, who are we going to help do what? In what context? What is the workflow? What is existing infrastructure? So in some way, Federico, I turn the question that you asked the other way. I say what we need to do is to adapt what we are doing to the infrastructure that exists. And of course, quite often, if you can show value from the infrastructure that exists, that often encourages the management, the people with the money, to improve their infrastructure because they can see the value in what they already do. It's very much easier to do that than the other way around. It's very much more difficult to say, I need all this infrastructure so I can do all those marvelous things. And they'll say to you, this infrastructure is expensive. How do I know you are going to do those marvelous things? It's easier to do it the other way. I have done some marvelous things with the infrastructure we have. Imagine what we can do with a bit more infrastructure that's a bit more in certain specific senses so I can do a little bit more of something more specific. That's much more convincing from the point of view of management. And in the roles that I have, or partly as a researcher and partly in terms of actually giving funding proposals, we know that, and Federico gets involved in that as well. So we see the importance of going to someone and saying, I need X money in order to fund so many proposals. And they always say, okay, why? So the benefit is always important. So the conclusion to what I'm coming, that I wanted to say is this. The technology, the availability of data, the availability of fast computing, and the acceleration in technology, especially the acceleration in technology, means that we can realistically address any of these areas. So the key question is always, who are you going to help, in what way, and how do you know when you've helped them? And once you've done that, then the methods and the data requirements will start to fit into place. And where you need your master's, your PhD, is so that you can have expertise in the appropriate data requirements. So for instance, in genomics, people are using language analysis to study genomics and find genes that lead to propensity for diseases or not. Systems biology now is really an area of bioinformatics, even almost more so than biology itself. And the same thing for a lot of pharmaceutical development. And there are methods such as graphical methods, conditional independence methods, and things like that that are fundamental in finding out biological pathways which go from the submolecular level to the molecular level and on to the disease itself in terms of the manifestation of the disease. The area of patient report and outcome measure is not even really starting to be studied. Care home is fundamental. Someone in the talk that I gave was involved with diabetes, I think it was Tatiana, and she was saying that actually it's clear that when you look at diabetes, quite often what is actually most important is not necessarily the having an expensive, sophisticated device, is how often and how carefully do you monitor yourself, the little simple things. And there are ways now in which we can automate that and produce e-health systems. In Africa, again, one of the things that could be health potentially, there's a lot of mobile phones out there, even in the countryside, might be telehealth and e-health, as well as automatic or semi-automatic interpretation of data at source, at the point of the user, that provides a filter or a screen that allows care to come or to be solicited when it is required. Public health profiles, I showed you some examples using CI maps. There are many methods now that are being used in public health profiles. Wearable devices is, again, there's enormous potential for measuring ourselves and to know when we are well and when we are not so well, so that we can have alerts before we get ill. And of course, social media, from information to disinformation, that is an area where AI is absolutely fundamental. So I think the question is not so much the infrastructure within the hospitals, is what do you want to do with AI? Now, within hospitals, there's a whole talk you can give about the infrastructure that's required, and whatever infrastructure you have, you can usually do something with it, whether it's just clinical indicators in a table, that, like the example I just gave of pregnancy viability. You could do that in a lot of hospitals, and we have several examples of that. If you use a transparent model that's going to be reproducible and understood by the clinicians, and then you can go right all the way forward to transformer-based models, attention-based deep learning networks, which are looking at images. And we saw an example on mammography screening, right, where deep learning was used to reduce the workload of radiologists by filtering out the most obviously negative cases, so that instead of them having to look at a very large number of cases, they have only to look at maximum 2/3, usually a third of cases, which are the cases that need more attention. So the answer to your question then becomes, we can do a lot with data. I'm just going to stop sharing. Stop sharing. Yeah, we can do a lot of data. It's up to us to make the best possible use of the data that exists. But the really good news from a research point of view is whatever question you ask within the healthcare setting, you now probably have access to enough technology to be able to make a decent go at answering that question. That is the most important thing to remember. And that is where the expertise then starts to come in. Your expertise as a data scientist starts to come in. I'm not sure I even answered your question, but I spent a lot of time talking.
You absolutely did. And actually, again, I'm very happy this is coming along so smoothly, because all of you guys are anticipating some of the topics that Adenauer and I thought of. And so there's another assist. I'm a very lucky, if I were a striker, like a football forward today, I would be very lucky, because I've got all these very creative wingers creating assists for me, Livia, Paulo, so allow me the football comparison, which in Brazil is always good. So I will use all of these assists from Paulo to involve a Vicent, and then I will actually, after Vicent chimes in, I will also involve definitely Adenauer, and possibly also maybe some other colleagues of ours here, maybe Mateus. But Vicent, let me ask you this. Basically, you know, Livia gave us a little bit of background on the infrastructure issues, and Paulo reminded us brilliantly how to come to, you know, this mindset of asking the right questions, even regardless of infrastructure, dealing with the powers that be, that have the money to fund our research. Now, we've been talking a bit about, especially with Paulo's intervention, about pros and cons, limitations versus potential. I know that you love really the technical details. Your talk yesterday was a lot of mathematics. That was great also for our students here. So if I had to ask you, I know it's a tough question, but I know you're a tough guy and you're used to my philosophical questions. So if you had to tell me, highlight the toughest technical issues, technical limitations, mathematics-wise. Now, let's talk also a little bit again about the mathematics. And what do you envision, which areas of the medical field do you envision now as the most mature, the most ready for a real translation, clinical in the sense that Paulo depicted? You know, when I said before, you know, I used the term, which is a very popular term, bedside, I didn't mean to restrict the field, but Paulo did a great job reminding us how complex are all the facets of healthcare delivery, let's say so. Because there's home care, for example, there are a lot of different tasks and divisions involved in a hospital. Livia mentioned briefly that as well. So the tough task for you is talking about, you know, since we're explaining limitations, we're debating limitations, Paulo reminded us again about transparency, about interpretability, especially he mentioned now in his last intervention. So let's talk also a little bit about, no, not infrastructures, not stakeholders, not who's going to benefit from our models. What are the main technical issues, mathematical issues we still have to face? And what are the fields that you see as the most mature now, most ready to benefit actually from, not just at the bedside, in a clinical setting in general? Please.
That's a tough question. Thank you, Federico. You know I love you too. Well, I'm sorry, but I can't, and I really can't decouple the mathematical issues to what Paulo was just saying, because they are intertwined. And I tell you why, without avoiding your question. You know I'm not a quitter. Let's take, you have your question, you know your workflow, okay? Then you have to make sure that it's adopted by the clinical practice, which links to your question. Of course, the model has to be explainable. So it has to be capable, or you have to be able to assess what or why the model is making the predictions it's making, because it's very much linked not only to the efficacy, but also to the safety and the security and ultimately the path to regulation of your model and therefore product. Don't forget that now across the world, all AI models related to healthcare are medical devices. You may agree or you may not agree, but this is the fact. On top of that, well, no, let me go by order. So if you want to make the models explainable, this poses another challenge, which is what Paulo just explained beautifully. They had to open up the box for their predictor of pregnancy viability. And this means that you have to make the effort mathematically to do that. They have been able to do so with the SVM, which is, it could be opened the way they did it. But for example, if you have UNet, deep learning, how the hell do you open that up? And this is a serious problem. So you have to take a surrogate approach. Okay, I'm going to do a GradCam. Oh, cool. I'm going to do an attention network. Cool. But then you will only know why it's making the prediction. For example, in my project with lung cancer, I can touch upon that later, right? We know that our networks are placing their attention in the nodule. That's cool. But then there's another derivative to that, which is interpretation. So how we humans are capable of interpreting that within the context of the patient, which links to another limitation. If explaining the model is tough, interpretation, it's even tougher, okay? Now, to the limitations in training. I touched upon that, for example, yesterday. For example, having invertible neural networks, it's still an open problem. So you don't know how to reconstruct an output from an input, generally speaking, okay? And why is that important? Because if you want to interpret and explain the model, you have to understand how it's constructed, and you should be able to go back. And it's not because I'm a freak mathematician, it's because my patient has the right of rebuttal. And they have the right of a second opinion. So how on earth am I going to give them the second opinion if I don't know how I've given the first one? Okay? And putting that mathematically, it's really, really tough. Okay? And then finally, the areas of application. I don't want to sound topical, but there are things that are quite mechanical in medicine, okay? And I won't claim to have a deep knowledge, but for example, writing discharge report should be easy because you have, for example, in the ICU, all of us, well, you and I have worked in ICU, you know what the interventions have been, what the maneuvers have been, you know what the outcomes have been. You want to transfer the patient to the floor, to the general ward, then you should be able to write this report easily. This is a quick win that we could start using these methods. There are specialties which are very technified, and we can think of intensive care, anesthesiology, radiology, and so on. And these are the ones that are basically or mostly related to seeing what's happening with the patient and with the monitoring. Okay, we all see now in across the globe how well, hospitals are becoming CPDs. And if you asked me 10 years ago if we would be able to install an H100 NVIDIA in a hospital, I would tell you, what are you drinking? But it's happening as we speak. And so going back to that, for example, there are other specialties where they don't much care about all these nuances. For example, in radiology, they want to know if there's a nodule and if there's not a nodule, which links to Paulo's point, which is intertwining your process with the clinical flow. And that's where I started my talk yesterday with my project in cancer screening. Out of our almightiness as computer scientists and data scientists and AI experts, we thought, okay, we're going to give them a TAC and we're going to tell a CT scan and we're going to tell them whether this is a cancer or not. This is not how the workflow works. They always take 2 scans, they assess the 2 scans, they see if the nodule has grown or the nodules have grown, then they perform a biopsy, they send it to another guy who's sitting in a lab, and the circle is closed by a cancer committee where you have radiologists, you have people who know pathophysiology, you have the oncologist, and then the specialist saying if it's a lung cancer, okay? And these guys all together make the decision, not you with a single CT. What I mean by that is, once you have this flow, then you have to prove that it works, okay? And you can put it in a context of screening and so on. And this is where the health technology assessment comes into play, which is actually measuring all these KPIs that Paulo was mentioning before. And if you want to make it to clinical practice, this is really, really important. So radiology, it's an area of application. Intensive care is an area of application. OR is an area of application. Step-down units is an area of application. Primary care and medicine, it's also an area of application. But once again, it very much depends on the questions and the support that you want to do. And I won't talk much more because I could go on for hours.
Thank you, Vicent. I know that you could say a lot more things, but I will get back to you and Paulo and Livia shortly. I would like now to finally involve also Adenauer.
I'm loving the discussion. Yeah. I don't need to be involved at all.
No, but you know, I think that the interesting thing where you can help us again, giving another assist to move through our topics of choice is that one. So you're a neuroscientist. I say you work with neuroscience. I don't want to define you. So, but your area is neuroscience. Okay. Yeah. And maybe later on we can also ask Matteo some opinions since he works with imaging. But anyway, here, yes, you know, we do have some infrastructural issues, but let's forget about them. Let's talk about the field that you work in. So neuroscience, I think, as far as the research is involved, the research problems, you can also do extensive use of advanced statistical data science methods. So that's a thing where I would like to hear from you, because now I want to, switch a bit from this general background that we talked about, and we talked a lot about, the medical applications. But I want to talk also about research applications. And talking about research, I also want to use your experience and your opinion to explore the boundary between research and also education. Because some of the things and I will get back to the three of you in a bit, some of the things we wanted to discuss today is also, we're talking about a lot of very fancy things that I'm sure the students are very interested in, about what AI can do, right? But as a researchers that have to ask the right questions, as Paulo said, and have to deal with infrastructure issues, whatever they are. And as educators, we have to be ready to probably change the paradigms of our teaching, right? Prepare different types of professionals and the better researchers. So I don't know how you want to tackle this from the side of neuroscience, from the side of education, but I really want to get into this with you.
Okay, great. No, what I can maybe do is briefly give you my impressions on the applications on neuroscience, which I think in general they don't suffer that much from the problems, because I think that what the Professor Lisboa listed for us, that good practices on AI are problems on the field today, as I see, because nobody seems to be paying attention to this in general. Just a few, all of you are paying attention, and this is great. It seems that we have planned this table perfectly, right? But that so many persons that work with AI, let's say in medical applications, and most part of the publications that at least I see, they are not so careful with questions and not so careful with almost all of them stop at the area under the curve. And so all these questions about calibration and so on and explicability are not there. But I think that in neuroscience, we are not that much contaminated by the bad practice of AI, because neuroscience is about the mechanism. At the end, what we want is to understand what is happening. And so we are using a lot of these techniques. I'm not an expert on AI, but almost all of what I do is with tools in computation, of course. And we are using all of these techniques to understand better what is happening in the brain. And so even generative models can be applied. For instance, it is being applied in the brain-computer interfaces to try, because they deal quite well with sequential data, and it's being tried in these interfaces to try to understand if we can capture some patterns and to predict things, but not with the intent only of classifying the objects, but more than that, to try to understand what is going on. So I feel that the neuroscience is not suffering that much. My main concern in this, connecting with you, what you said, Federico, is actually that when I hear Professor Lisboa talking about the good practices, when I hear Livia talking about the importance of science in this, and also when I hear Vicent talking about all these difficult technical questions that are involved that we need to understand, I feel like we have maybe the universities as part of this evolution are somehow failing in one of our roles, because I think that we should be the ones more critical and more rational and to understand the methods and to point, as Professor Paulo is doing, to point to the right direction in the evolution of this field. I don't know if you have this. It would be great to hear from you if you think that the universities are the weak link in this, because I understand completely a startup trying to catch up with all the methods that's going. They need to innovate. They're doing a lot of things. Just to understand the methods is difficult. There are so many new methods every year. But we at university, we can be more careful and more rational and try to explain things that others are not understanding. And do you think that we are failing somehow in this evolution, or I don't know what I'd like to hear? Maybe Professor Lisboa could hear us.
Yeah, I would like to. I was just nodding because sadly, yes, and I'm talking about generally, I'm not talking about any one particular group, but sadly, yes. And this is partly because we are hostages to the power of technology. Technology, particularly deep learning models, are so powerful. It's easy to fall into the trap of believing that they are magical boxes. And there is particularly around, I mean, you guys are working in biomedical engineering. That's a great place to work because you have a perspective of the practicality of what you want to do. But when you look at computer science in particular, I have come across a lot of computer scientists who feel that what they are doing has nothing whatsoever to do with statistics, which sometimes actually what they're doing is essentially statistics, okay? Now, not always. I think in the days of shallow neural networks, that was very much the case. In the case of more complex neural networks, that's a bit less the case. I think computer scientists now are adding a lot of value, but there's still an element of that. So there is very little appreciation of the importance of understanding the model. The reproducibility of your research is fundamental. And sadly, that's not even true of just neural networks and machine learning. It's been true in medical statistics for many years. So all those issues, but it would be really good if people in all the different specialisms within universities improve the training that they give so as to have a broader perspective of the importance of their subject and how that subject might translate into practice. So in some way, one of the reasons why I like to engage with these workshops, and I'm retired now, so every time I engage, I mean, at the moment, kind of my wife is saying, what are you doing? I got my daughter moving house, and she's got a kid. She's looking after the kid. I've been looking at, just down here, I just show you this. I shouldn't show you this because it's being recorded, but just down here, there's a cot for a baby, which is in the study, because that's where she sleeps. That's where she's been sleeping overnight. But the reason why I engage in these things is like I'm on a mission to try and promote the fact that people need just two questions. People need to start by asking good questions, and secondly, they need to understand the models. Just those two messages. And it's quite often the case that those messages are not understood very well. So to give you an example, I mean, again, just to touch on, for instance, what Vicent was saying, which I fully agree with. Discharge reports could be a way where you could use some form of generative models to produce some things, but you got to be careful. I was just reading just today by accident something about the legal profession and the use of ChatGPT. And this one doctor in America, I don't know whether you've seen this, it's the first time I saw it. This one doctor ended up in court himself, right? And the reason why I ended up in court is because he was there was a trial involving some company that was some individual that was taking a company, I think it was an airline, on a personal injury case. And when this trial went to court, there were 7 cases of precedent that were quoted, right? And the airline said, we don't recognize 6 of those. And when they looked into it, they found they never existed. And then the guy came back to his research department and said, where did you get them from? Well, I went to ChatGPT. Okay? And the interesting thing is, if you then look at the actual exchanges with ChatGPT, that was a really interesting thing. This guy didn't just go to ChatGPT and say, give me precedents for like this. He thought, this doesn't make I'm not completely sure about. So he asked ChatGPT, are you sure? Is this a real case? ChatGPT said, yes. Where is it recorded? And ChatGPT said, it's recorded in this place, that place. So he was convinced there were real cases, and there weren't real cases. So ChatGPT is paying a price for the fact that we're going outside of, as Vicent said, outside of the specific remit. You go into a generalized remit, but then it is possible to create information that wasn't there, isn't there, and sometimes it's not even correct. So I always say to students, yeah, I'm not against using ChatGPT. It's a great way to do preliminary research, but then you need to check the facts. Do not rely on anything that comes out of it. So that will be the issue in terms of writing a report, a formal report. You have to be careful that ChatGPT is making good use of the data you got. And there are other examples. So for instance, another example that I know, I think, Vicent, you did work on sepsis as well, and I think Federico worked on sepsis as well. And at one point, I got involved in sepsis. It's always a difficult area, and the first problem that you have, I just give you an example on how important it is to ask the right questions, is that most models of sepsis are trying to predict mortality, right? And mortality is 10%, right? Now, I can show you very, very quickly on a piece of paper that if mortality is 10%, then even a classifier or a predictor, it doesn't matter how complex it is, even if it has an area under the curve of 0.95, is always going to make at least as many false positives as true positives. Usually twice, most likely 4 times. Okay, right? And that's the next thing, which relates to what you were saying, Professor Casali. It is this: not only do we need to change the understanding of AI by the universities that are teaching AI, but within the clinical environment, we need to change the understanding of AI by the doctors. I don't mean the understanding of the details of AI, but or what it is the doctors want to do. So when I spoke to a doctor about sepsis, right, the doctors a lot of doctors, not all of them, are basically saying, yeah, the prevalence is 10%. Essentially, I want your system to tell me who's going to live and who's going to die. And then I say, well, actually, I can show you mathematically that's not possible. I can tell you for every person, for every case I say it's going to be a true positive, there'll be probably 4 false positives. And they say, well, in that case, I'm not interested, right? And I say, hold on, maybe you are interested. Maybe what you're doing is you asking the wrong question, okay, right? It's like the early days of insurance companies when first someone discovered they could predict probability of people making claims. And they say, I can predict, Mr. Manager, 10% of people are going to make claims. And the manager said, I'm not, that's terrible, that's no good at all. I want you to tell me which 10%. In other words, which individuals. And the same thing happens. Even though you cannot predict who's going to live, who's going to die, what you can do, if you have an area and if you have a good model, then you got a lot of predictive power there. So how do you get it out? What you can do is you can stratify. You can say, well, what I can do is I can tell you 20% of your patients that are going to have 5, 6, 10 times the probability of death from the other 80%. And that is reproducible. I can give you those 20%, I can stratify that, and you can run your trial, and you'll find that 20% of those patients will have a higher mortality rate. So I can't tell you who's going to die, but I can tell you which group is at highest risk. Now, if there's something you can do about that group, if you can maybe change the frequency of observations, if you can change the medication, the treatment, then that is going, and that is how you're going to get power out of the method. But the point is, it's not fair on the doctor to say to them, the doctor is going to say, just predict who's going to die. Say, well, actually, it's no good. And you could easily walk away and say, I can't do anything. But actually, you can. So there's education to be done at the level of technicality, of the technology, technical education, but also at the level of the end user. I'll stop there so that people can have a go.
Yeah. No, Vicent, I'll let you comment. Just allow me a quick comment for a second. Again, you raised already some of the topics that you wanted to come to end this discussion. So I will let Vicent comment. I will double check whether Mateus is still with us and wants also to chime in, and then we can definitely come to the final. Okay, Mateus, let's just have Vicent comment, and then I would like you also to chime in. And then, some of the things that Paulo mentioned are perfect to come to the end of our discussion, which will be tough for all of you. We'll also get back to Livia. Let me just to make it lighter, I just want to share my screen for a second, because what Paulo mentioned and the story of this jury case, well, this court case in the US, I can't forget, you know, this meme. I know we're in the meme era, whatever that is, but this is one that I always like, and I send it out to people when they send me something that is very suspect. Let me know if you see my screen.
Yeah, it's good.
Let me see. It's loading here. Okay. Great quote about the internet unreliability by Abraham Lincoln. So, you guys seen that? Does it make sense? I'm asking our students. Do you believe Abraham Lincoln when he criticizes the internet? Do you?
Of course I do.
No, you do, guys. I'm asking our students because, you know, they look at me like I'm crazy. I'm not crazy. I didn't create that. But it's something that I always like to remind, and I think it matches very well. Because now, you know, ChatGPT is because this is a meme about, you know, possibly fake news and stuff like that. No. Now we're going to have this with ChatGPT. Oh, ChatGPT found that. ChatGPT gave us this answer. And now ChatGPT is apparently creating court cases that never actually happened. And ChatGPT will fabricate data. And this is not about, I mean, we would have to talk about a lot of stuff. We don't have the time. This is not about virtual clinical trials, okay? This will be fabricated data that will be useless for virtual clinical trials. We'll fabricate papers. So, but the ethical implications, we'll get to that in a bit, okay? So Vicent, please, I'm sorry for taking your time.
Yeah, I wanted to touch upon these two things. I learned about the mortality the hard way, Paulo, because I started with mortality. You evaluated my PhD, and then by revisiting the data and asking what happened to those patients who didn't die in the ICU, I just discovered that 95% or almost everyone died at day 100. So I created a full PhD on something that was flawed. Anyway, my message here is, if we can stratify, as you were saying, the patients, put them in a trajectory and see those who are going to fare better or who are at higher risk and adapt this dynamically, then we may be up to something that is really, really useful. Because as one doctor was mentioning in this congress that we attended last month, I think, he said, I'm not treating sepsis, I'm just treating organ dysfunction. So I'm lagging behind. So he has his clear certification, he does something based on the status of the patient. So we need to start thinking more adaptively instead of trying to become God and say, you are gonna die because your SOFA is above 8, your Apache score is 32, and your lactate levels is 3.9. No, because actually the second point is that, well, future, as the adagio goes, it's difficult to predict. And also if you adapt, then it's becoming more and more difficult to predict. Which links to the problem of ChatGPT and all these applications that we see. We always have to, and I said that yesterday, check your sources. And we know that ChatGPT is inventing articles, is inventing cases, and so on and so forth. So we have to be careful, and I'm going into the ethics of not giving away our empowerment and our power of decision, because I have no problem in letting my GPS drive me to the other side of Barcelona or even into France. But there's absolutely no way I would write an article based on references from ChatGPT or run a patient anamnesis with ChatGPT, because my chances of doing that wrong are just huge. So I think we have to be very careful with the empowerment and giving away our decision power, because then we are going to be in jeopardy. So it's not as one colleague of mine is saying, she's not concerned about the race of AI, she's more concerned about the race of human stupidity. So that's.
Remember, I once was talking to doctors, intensive care doctors. That was 2019. I said, oh, no, people started talking about artificial intelligence. And I asked the question, does that solve human stupidity? So, oh, yeah.
No, just taking the point that Professor Lisboa brought about education in medicine also. Maybe we could hear from Livia. I heard something about careers now that are being taught in the medical schools that somehow integrate or blend medicine and computer science careers that are mixed like this, so that because physicians should have enough knowledge, briefly, to interpret the results of these algorithms, to even to craft prompts for their needs, and do not trust everything that comes out from that. Understand how to avoid these biases that are inherent in these machines. So what do you think, Livia, about this perspective of maybe what some of our students that will be graduating in biomedical engineering will be teaching medical doctors in the future? What do you think about that?
Well, I have a very controversial opinion about the teaching for medical students, because as you said, as we saw, at least during pandemic COVID, we have to remember that medicals, they are not scientists, they're kind of technical workers. They are trained to do something, and they have to follow that strictly, because if they don't, they can get some. They can be sued. What I'm saying here is we still have problems for some medicals to understand papers or to understand methods. Sometimes they can they answer very well to orders, like some guidelines. They answer if the Ministry of Health say them to give some medicines that maybe the medicine doesn't have a lot of proof that works for some disease, as you saw here in Brazil for specifically kind of disease. You answer anyway because they are trained for that. So first, we have to work on literacy for science, and a lot of graduation courses and undergraduation courses we have. And digital literacy is something also we have to teach, because we take for granted that if everybody uses computer, they understand what happens there. For a lot of people, Facebook is the internet. There's no other thing. There's internet. It's like Facebook. Everything came from there. The news, the jokes, the histories of people, everything comes from there. For us, we know that we have Google, we have a lot of sources to look for, Wikipedia, any other places to search. But this is not the reality. The digital literacy and the critical thinking for the answers that you get from the computer, not everybody has. So we have to teach that. Even for MDs, for people, for superior teaching, I don't know, like for people in college, some of them don't have that. So we need to go through this before kind of judge them for using GPT. I am also a teacher in science, computer science in a college here in Ribeirão, because although I work for Einstein in São Paulo, I'm Ribeirão Preto. So I'm teaching here. And everybody, I know all my students are using GPT now. And sometimes they don't have the difference between what they are saying and what they are writing. So it's something that doesn't agree with we are talking about, or the things they're teaching. The critical thinking is kind of getting lost, and they already have papers on that. How people just trust GPT, just trust what they saw in the internet. Fake news is this, but like in a huge level now that we have this so friendly telling them that the truth is this. So I have a discussion in a journalism course here where we are saying like how the GPT will impact on news, and how the journalist has a way they need to learn, they need to understand the tools, and how this is you impact reality. I would like to just cite another researcher, Kathy O'Neill, from the book Weapons of Mass Destruction. This is a book that everybody that wants to work with AI must read. That woman's amazing. If you don't want to read the book, although you should, you can go to Netflix and watch Coded Bias. It's the context is there as well, but they are saying how these models that are closed there are very spreaded and nobody knows how it works. It's giving prejudices to people and making the world more inequitable than it was before. Although we want to make it a better place, these models kind of making the world a worse place. So you really need to think about critical thinking. Don't take for granted that what your MED are saying to you, please. Asking for a second opinion always. And try to help people that sometimes doesn't understand what that means to use the GPT. And always thinking about the answers, about the impact are you going to have in the future. I'm always just one more thought. I stop soon. There's this. I don't know if everybody knows, but I'm a woman in IT, and I know I learned before that AWS and Amazon just released a human resources algorithm that actively excluded women from interviews. They have this sexist algorithm that from some proxies, from some other analysis, not gender exactly, that just excluded women from get the chance to get interviewed because the way they defined success for that model was biased. So the way and the need to understand what is success for your tool can have a huge impact, not only on your results, but also in the life of people who are going to use it. So this is something very close to my heart. IT and ethics on AI is something you need to take a really, really deep thought and care about it. So now I finish. Thank you.
Oh, thank you, Livia. So we have 20 more minutes, and it's great that once again you anticipated one of the things that we will go through for the end of our debate, which is also the ethical implications. But let me get back to the four of you for your quick final remarks in answering to my provocation that I will soon bring up. But Mateus, I would also like you, as another member of our faculty here with me, with Adenauer. So first of all, you work in a field research-wise, and also as an entrepreneur, actually, with your startups. You work in a field that is. Are you sharing your screen?
Yeah. I will provoke all of you again. But
is that your field? With imaging, you probably do. You really benefit from AI techniques. The other thing is that you're always very sensitive to, these educational implications, with the students and what Adenauer, Paulo, Vicent a little bit as well, and Livia have mentioned. So I would like your take on this, and if you have some provocations with your slide, even better, right?
Yeah, I'll try to introduce some more important topics to hear the four of you, Lisboa, Livia, and Vicent. As Federico said, I work with medical imaging. When we talk about medical image, mainly the first thing that comes in our mind is radiology, isn't it, Vicent? And when we talk about radiology, I have been feeling extreme of emotions in this field. Livia can contribute also with the perception that she has in Einstein. Well, so I will put here three questions before I will contextualize. So to provide AI service, we need an important facility, important infrastructure. I always show this to my students. Actually, in radiology now, 10, 20, 25, 30 years ago, the service was provided in only one place. Only one place. The patient goes to a place, acquire the image, the radiologists were there, and after a while, the patient or the doctor, actually the medical report would be sent to anywhere, even by post. Now, AI serves at AWS, the cloud computing is providing an advantage of where it can reach, as Livia said, a patient from Africa can benefit from a radiologist here in Brazil. And even more, we can provide AI service in this cloud to help radiologists to make their medical report. And now I will give it to you guys some questions. I'm always involved on this topic because I advise on this topic and teach on this topic. Now I'll give back some questions that I received from some audience. First of all, yeah, here in Brazil, I can see a huge opportunity in radiology. Yet I can see this in the academic and scientific way. When we talk about service, I can see two very delicate and concerning questions that have been asking to me all the time. First of them is, will it replace radiologists? The second one, if there is any fault or any problem that results in a negative outcome, who is the responsibility? When I'm talking about like as an entrepreneur now, we have some, I don't want to tell my opinion, to not influence you guys. Basically, this last question, when we talk about responsibility, we can come back to the whole infrastructure that has to support the AI solution to give a good job, and can come back to the beginning of our presentation about the data. So I would like to hear your opinion in England with Paulo, in Barcelona with Vicent, and here in Einstein with Livia. Thank you, Federico. Help to contribute.
Thank you, Mateus, because actually, especially your second question is great for, some of the final considerations that we wanted to come to. Of course, doesn't mean that the other two questions are not relevant, but, you talked about responsibility or even accountability, right? Because at this point, we're just delegating, and this is along the same lines that Livia mentioned. We're delegating to ChatGPT or the AI, anything in our lives. And you, of course, talked about the clinical or medical problems, like in radiology, for example, and all the flow of information, right? As you showed in your slide, hospital, doctors, patients. And then, Vicent also said, of course, the issue of second opinions. So, when you talk about accountability and responsibility, there are two things that I think we would like to come to end our discussion. One thing is that you touched upon, Mateus, that Livia touched upon, and also Vicent and Paulo, of course, their interventions, their comments dealt with. So ethical implications. And, that's great that you said responsibility and accountability, because it's not just a pure logistic issue. There are ethical implications. The other thing is also, getting another assist from you, Mateus. And also, the discussion that Adenauer carried on earlier, especially with Paulo. We have to think possibly of a different biomedical engineer of the future. So I will introduce these last 15 minutes in this way. Quick takes, quick, because really, we have to make it by 10:20 here. Ethical implications. Where do you think we stand with this? If we're safe, or if we're getting on unsafe territory? This is definitely uncharted territory. Is it getting unsafe as well? Number two, since we talked about changing the paradigm of education, how do you envision the role or the figure of the biomedical engineer in the future? And I will introduce this quoting Paulo again. I really loved your title, the title of your talk. So your opening lecture title was The Coming of Age of AI. Okay, so coming of age of AI, but also coming of age of a new era biomedical engineer. So how do we want to go through? I would like Paulo to close because, you know, you opened our workshop. We're not done yet with this roundtable, but I want you to be the last to comment on this. I will randomly go. Adenauer, please.
No,
no,
I will not talk. I want to hear from them. I'm just maybe for Paulo, what we really want to hear from your opinion is that what should we in universities be teaching for our students that we are not teaching, and what should we not teach anymore? Right? At least it seems to me that we need to change some of the things that we're doing in the STEM field in general. I understand the point that Livia brought for about the education of medical school, but we have to face some of these problems in the university, and this is one thing that for our group here we are very we're trying to go ahead and trying to change the way that we teach in order to provide a better future for our students here. And so, in your opinion, what no longer needs to be taught? What's going on there in Europe? Are you changing curricula for biomedical engineering?
Okay, then let's do.
Wait,
Paulo close.
You're on mute. Sorry.
Your microphone.
You lost your sound.
I lost my sound.
Yeah, talk again. Yeah.
I didn't know that. No, I'm just saying, let's give Livia and Vicent 2 minutes each. And so we will close with Paulo, as I previously said. Livia, please. I know it's tough in 2 minutes, but...
Yeah, I kind of lost what I should add. The discussion was so intense that I just... Where we are in ethics.
Give us your take on... No, give us your take from a different standpoint. You're not in the academia, about the bioengineer of the next future.
Okay. First, where we are going to, this is something that I cannot answer. Like 6 months ago, I would never think that we can't achieve a language model as like GPT. So you kind of, what you have to be, it's very adaptable, if I can say that, because there's a lot of things appearing every time. Of course, GPT is already around on us because Google had this model since 2019. Okay, they decided not to release because the company was afraid that it would be too controversial. So they just hold on, but it's still published that. And then another company just discovered this treasure and just put out to the world. So this is something that it's kind of evolving over time. So the first thing I would say to students that if you want to go through this career, never stop studying, because this is something that it's changing all the time. So you have to want to learn new stuff. You're going to have your safe ground, the thing that you're very maybe specialist and make your safe place. But there's something out. Everything is always changing. So let's keep it in this way. In where I work now, it's the path we're following. We have a lot of projects. It's projects from 1 year, 1 year and a half, where you have to develop some models. We have to evaluate the models and then deliver to the client or the partner who's working with us. What we're trying always to do is guarantee that the model is at least safe, because our main goal is do not make harm, as said for doctors, medical doctors. They at least, if you cannot do good, at least do not do harm. It's something something we also discussed in Dakar during the meeting. Everybody was saying, like, we don't know where you're going, we don't know if this has future, but what you're trying to do now, the main goal is not do harm, and if possible, do some good. And if you do some good, keep doing good. So things it's going to improve. So this is my take. I know I have only 2 minutes, so yeah, I'm stopped to talking now. Thank you.
Yeah, well, it would be great to have more of this, but maybe Vicent, before we pass to Professor Lisboa, could comment also on the question that, more on the question that Mateus asked, that I think is very important about who's responsible, and what's your take on that?
Yeah, I absolutely agree with Livia and abiding by the principle of beneficence. And by that, I mean, nobody should be left behind. And this means that everything should be as unbiased as possible. And you should know, and if you're leaving somebody behind, you should give them alternatives, which links to Mateo's problem. I'm very much concerned, not very much concerned about who is responsible for a system failing, because there's always going to be a corporation behind it. And the law is very clear about that. What's really scaring me to death is what will happen when, for example, radiologists become sloppy because they are so hooked to the responses that they get of the system. How do we measure that? How do we guarantee that the standard of care will not decrease by giving us humans super perception powers as we get with all these models? So just to wrap up, I think that we need regulations, we need to be unbiased, we need to bear in mind that it's making good people better, but it's also making bad people worse. And what lays ahead of us, we don't know what it is, but it's going to be for sure more predictive, more preventive, more participative, and yeah, even more precise if possible. So that's my take.
Thank you. Professor Paulo.
Right, this has been a really big build-up, so I'm not sure I can do anything that is going to satisfy everyone. But a couple of points. The first one is accountability. I agree with what Vicent said. There's usually cooperation behind it. But the legal doctrine that applies here is the doctrine of the learned intermediary. That basically means that whoever takes an action is responsible for that action and for all the tools that are used in arriving at that action, right? And this is something that is worth considering as part of another question about education of engineers and doctors, that what they produce will have consequences. And those consequences then, the exciting thing for me is that they translate into exciting mathematical questions. They translate into questions of explainability, of interpretability, of reproducibility, of evaluation. And those become really exciting and some of them very difficult, some of them partly answered mathematical questions. Sorry, Adenauer, you're on mute.
No, sorry. Continue. I was just talking.
Oh, sorry. Okay. So that's the first thing. The second thing is what's called technological deferral. I think, Mateus, you were referring to that as are we going to just do with it? Are they going to replace the person? Okay? Yeah. So the answer to that is really we need to devise systems that put the person in the loop. And probably most people won't have noticed that. But in one of the early slides in the talk that I presented at the start of this, so it's a good place to end as well, I showed a system on abdominal pain that showed benefit and was never used very much. But that system was developed starting in the 1970s and evaluated into the 1990s by someone called de Dombasle. But there's something that was in that system that I've never really seen in any other system, which I think should be in every system that is decision support for medicine, which is this. That system basically was about looking at symptoms of abdominal pain and identifying what were the possible conditions and what were the possible rare cases that were associated, essentially provided a digest of the database with relation to those symptoms. However, before the system said anything, it asked the user, what do you think? That was an essential gate. Because part of the system was a Bayesian system. Part of the system was this. At the end, you would say, well, you think this, the system thinks this, okay? And here are the things you can do to check the difference. There might be, look again at these items or carry out these tests. There was an action. But I think this is something that should be required of all systems. What is it that you think? And only then will I tell you what I think. Because otherwise there is a danger, and I have seen this. I'll give you another example. I used to do a lot of work on breast cancer survival. And then there was, we produced some survival models for breast cancer. Then I heard about the system. I don't know if some people use it. It's called, well, I probably better not name it, but it's a big system that's on the web, which says it's for research only. And I was giving a talk at the specialist hospital, Christie Hospital, one of the best hospitals in the UK for cancer, especially for breast cancer. And at the end, someone came to me, so this was a talk to doctors, not to engineers, said, yeah, there were some issues because this system indicated the potential efficacy of therapy for breast cancer. And this person said he was examining an MD, doing a vial for an MD, and was looking at all the cases that this person had done. And there was one particular set of decisions on breast cancer that the examiner wasn't sure that was correct. So he asked this MD, why did you do this? And the answer came back, I just looked at the system. And this is part of a human weakness. The fact that life is full of ironies, and one of the biggest ironies of IT is that sometimes the better it is, the more dangerous it is. A system that's so good, people get so used to getting the right answer, they forget about thinking for themselves. So there's an element of serious psychology that needs to be done into this. It's around making sure that the person is forced to make statements before they can consult with the technological advice, so as to make sure that they retain their ownership of the decision and not just pass it on to somebody else. And then finally, what should we teach? I'm afraid the short answer is that our curriculum in the UK is probably not that different from anywhere else. We still get very technologically focused. But I used to be head of department, and in my own department, which was really a department on mathematics and statistics and computer science together, I started a second-year course on ethics that students attend. It wasn't just specifically about AI. It also touched on issues like the importance of things like Facebook, the impact of technology in relation to body image, mental health impact that was being had on youngsters. And I had a mixed experience. It's funny, some of the students were quite keen on it. Some of the students clearly did not want to engage with that. They just didn't, even though they are the age group that sometimes was suffering consequences from this. They didn't want to face up to them. They didn't want to think about them. They didn't have, okay? But certainly, what I think is something that would be useful to include in biomedical engineering curricula in particular would be at least some form of minor on human-centered AI. Human-centered AI. How can we develop engineering that's going to be there specifically in support of the person? And that brings all the issues around asking the right question or asking a useful question, measuring success, and talking about these things at the beginning of the decision-making process about what model to use and what data to use and what maths to use. Plus the fact that then there are lots of other things to talk about in relation to the regulatory environment and the strengths and the weaknesses of the regulatory environment, the ethic, and you can include as much ethics as you want in terms of responsibility, and also the areas of that Matthias was pointing out on technological deferral and accountability. So I think that there's enough material to make a technologically, certainly an engineering relevant course on human-centered AI that could really make a big difference in increasing the level of critical thinking in biomedical engineering. It's probably as far as I can go.
Perfect. Perfect. Thank you so much. So we're finally ready to have, our room thanking you. Well, let's see, is it turning on?
Yeah, okay, we can see. Here's where we are, huh?
Yeah, we were sitting in front of each other, now we're not.
Yeah, everybody is
and
there.
here.
Okay. Thank you.
I would like to thank all the students for staying the distance.
Yeah. You saw me waving because we were all scattered, so I said, "Hey, group together." So sorry.
I thought you were wishing to stop them leaving.
No, actually, no. They don't want to leave. They want us to, go on longer. But we have another speaker coming up after this, and I'm gonna chair him again. So, anyway, thank you so much, everyone. I mean, wholeheartedly. I'm sure that thank you, Adenauer. It was great that you and I were able to put this together. Thank you, Matteo.
Thank you, guys.
Thank you.
Thank you very much,
Professor Karina, who's chairing the whole workshop. Thank you, all the students. I hope you enjoyed that. We're just sorry we can't really open for questions, but our schedule is brutal and the topic is so rich and dense. And let me just leave you with this. Hopefully one day we can all meet in the same room next time, somehow, somewhere. Yeah? Okay. All right. Thank you so much. We'll keep in touch, of course, with all of you. Thank you. And thanks. No, that's all I can say. Obrigado. Gracias.
Obrigado.
Thank you. Bye-bye.
Obrigado.
Obrigada, gente.
Tchau.
Tchau.
Tchau, obrigado.